Hi friends of Work, Learn, Share, Develop. Today I'm gonna show you how to implement a Compass app for Android. In the link description you will find a link to our website where you can find all the text of the operation of the implementation of this app. If you have any question, you can contact us on the comment box below, or you can find us on Facebook. Let's begin. So, first of all, we open Android Studio. We go on Start a new Android Studio project. Under application name, we write Compass and we click Next. In this box, we leave all as it is and we press Next. We select Empty Activity and we press on Next. And then in the last box, we change the activity name to Compass. Then we'll press Finish. Okay, our project is ready. Now the first file we are going to modify is the Android manifest.xml that is under app manifest. In this file we had this line, so screen orientation portrait, that defines the orientation of our activity. In this case, it defines that the activity of Compass will be in a portrait orientation. The second file we are going to modify is under res layout and it's the activitycompass.xml file. As you can see, we have two modes of modification. We have the design mode and the text mode. We will modify this file in the text mode, so we pressed in the tab down below. This is the file of the layout of our activity. In this layout, we will define a text view and an image view. The text view will contain the azimuth of our sensor, and the image view will contain the image of our compass. As you can see, by default we have this text view. We use it for the azimuth. So first of all, we change the layout width to match parent. Under layout 8 we had center horizontal, true. Then we align the text to the center, so text alignment center. We define the text size of 40 SP. Then we define the text color as black. We define the style as bold. The primary text as 0 degrees. And then we define an identifier, ID, and we call this text view txt azimuth. This ID is very important. It provides us to specify the position of all the components in our layout, and it permits to us to get the reference in our code. Okay, after the text view, we insert the image view. Width, we say match parent. Height, wrap content. And before taking the image, we have to take the image that you have downloaded of the compass, and we have to copy into the folder of our project. So we move in the folder of our project, we go under app, source, main, res, drawable, and we copy the compass.png. Now we can import this image in our project. So we return in Android Studio. Under layout 8 we say source, we write compass, and as you can see we have drawable, that is the folder, and this is our image that is named compass. Then we say okay, the image view will be below text azimuth, and we define also for the image view an ID that we say image compass. Now if you move into design mode, you can see that we have our text view and our compass image view. Okay, now we have to go into our code, so we move into the file compass.java. The first thing we are going to do is to implement the sensor event listener. So here where there is app compass activity, we write implement sensor event listener. Then you have to press the keyboard button Alt plus return and you select implement method. You keep selecting these two methods and you press OK. As you can see, we have two methods. The first is onCensorChanged. This method will be executed every time the sensor we need for this application change its state, so where we can get the information. This method on accuracy change, we don't need it, so we don't use it. Okay, before starting implementing this method and to add others, we have to declare the variable that we are going to use in this code. First of all, we need the image view and the text view reference. So, image view, and we call it image compass, and then the text view that we call txt azimuth. Then we need an integer variable for the value of the azimuth, int azimuth. Then we need the variable of the sensor manager. We need the variable of the sensor we are gonna use, so sensor and rotation vector, the accelerometer and accelerometer, and the magnetometer. Then we need 4 metrics to store the information about our sensor. So we need, first of all, a float matrix that we call mat, and we declare it a new float of 9. The same for this matrix that we're going to call orientation. And then we need 2 more metrics. So private float, one for the value of the accelerometer, new float of 3, and one for the magnetometer. Then we need 4 Boolean flags. So we need 2 flags that show us if we have or not the sensor. So have sensor equal to false, private Boolean, and another variable that we call sensor 2, and we set equal to false. We need also other 2 Boolean variable that we call last accelerometer set. So if we have data from the accelerometer, the same from the magnetometer. Okay, now we have all the variables we need. The first method we are going to implement is the onCreate. So we move here. First of all, we take the reference to the sensor manager. So sensor manager equal cast sensor manager get system service sensor service. So we do the same thing for the image view and the text view. So image compass equal image view find view by id r dot image compass. That is the ID we have provided to the layout, as you can see is image compass. And we do the same thing with the text view. So txt azimuth text view find view by id r.id dot txt azimuth. Then we call the method start that we are now going to implement. Okay, we move down the method on accuracy changed and we create the method start. In this method we are going to check if you have 3 types of sensor. The rotation vector that are the gyroscope and the magnetometer sensor together, and if we don't have it, we check if we have at least the magnetometer and the accelerometer. If we don't have any one of these, we call the method no sensor alert that show a message that our device doesn't support this application. So, first of all, we check if we have the rotation vector. So sensor manager dot get default sensor dot type rotation vector. If we don't have it, so if it's equal to null, we check if we have the magnetic field sensor and the accelerometer. So if sensor manager dot get default sensor dot magnetic field, it's equal to null. So if we don't have it, or we don't have it the accelerometer, so if it's equal to null, we are going to call the method no sensor alert that we are going to implement after finish implementing this method. Instead, if we have the magnetic field and the accelerometer, we have to instantiate it. So else accelerometer it's equal to sensor manager dot get default sensor dot type accelerometer, the same thing for the magnetometer, so you can copy and paste it. Magnetometer, the type is magnetic field, and then we have to set to register the listener that will use the method on SensorChanged, and by registering it we can use have or not the sensor. So have sensor equal sensor manager dot register listener, this in this case accelerometer, and then we have to set in which time update its data. We select sensor delay UI. We do the same thing for the magnetometer. We change of sensor to a sensor 2 and accelerometer with magnetometer. Then we have to do the same thing with the rotation vector. So else, if we have the rotation vector, we say okay, rotation vector. As you can see, I write rotation, so rotation. So rotation vector it's equal to sensor manager dot that get the full sensor dot rotation vector, and we register the listener, the Boolean value f sensor, and we change this to rotation vector. Okay, now we have implemented the start method. Now we had the no sensor alert method. So public void no sensor alert. In this method we create an alert dialog. So alert dialog dot builder, we call it alert dialog, it's equal to new alert dialog dot builder, this. Then we are going to set all its characteristics. So alert dialog dot set messages. If we don't have the sensor, we can show this message that tells to the user your device doesn't support the compass. Then we say that this alert can't be cancelled, false. So we can't click on our screen to close it, we have to push the close button. So we define the negative button, that we call it close, and we define the what we do when we press the close button. So we say dialog interface on click listener, so when we press the close button we close this activity and we close the application, so finish. We had the semicolon here, and now we have finished with the no sensor alert method. Before going to implement the OnCensorChanged method, we have to add one method and two override. One is the stop method, public void stop. So, if have sensor and have sensor 2, so to stop the application we have to release the sensor. So if we had the accelerometer and the magnetometer, we have to unregister the listener. So sensor manager dot unregister listener, this accelerometer, and we do the same thing with the magnetometer. Then else. Instead, if we have only the variable have sensor, we have only the rotation vector, so we have to unregister the rotation vector. Okay, now we have to override the onPause and onResume method. So override protected void onPause, that is the method that is called when application goes in the pause state. So super onPause, if our application go in the pause state, we stop the capture from the sensor, so we unregister the listener with the stop method. Instead, if we resume our app, so protected void on resume, we have to restart the catching of our sensor, so we are going to run the method start. The last method we have to implement is the OnCensorChanged. So here we change sensor event is name only with event. Then we check which sensor is getting the data. So if event.sensor.getType, if we are taking data from the rotation vector, so sensor.type rotation vector, we have to store the rotation matrix data in the rotation matrix. So sensor manager dot get rotation matrix from vector rotation matrix, and then we take this matrix from event dot values. Then we compute the value of the azimuth by doing a cast with the integer. We convert the value in degrees, so math to degrees. We get the orientation matrix from the rotation matrix, so sensor manager dot get orientation. We have the rotation matrix, then the orientation matrix where we store the data, and we took the first value, that is the azimuth. Then we have to take this value, sum 360, and doing this operation, With this, we have restrict the azimuth from 0 to 360 degrees. Okay, then instead, if we have the data from the accelerometer, so we can copy and paste and change only the type. We copy the array value, so system.arrayCopy event.values 0, event.value 0. Last accelerometer, we copy the data on the matrix last accelerometer 0. The length of this will be the length of the vector values. Then we set the Boolean variable last accelerometer set equal to true. Then, if instead is the magnetometer, so else if we can copy and paste type magnetic field, we have to do the same thing. So we have to copy the array, we change accelerometer with magnetometer, and the same with the Boolean variable. Then, if we have received data from the magnetometer and the accelerometer, we can compute the azimuth value. So, we take the rotation matrix, so sensor manager gets rotation matrix, we have RMAT, then null, then we have the value of the accelerometer and the magnetometer. And then we get the orientation matrix by sensor manager get orientation RMAT, then orientation, and we compute the azimuth as before. So we can copy and paste this line. Okay, to be sure, we round the value of the azimuth to an integer, so m azimuth is equal to mat dot round m azimuth. We set the rotation of the image compass with respect to the azimuth, so image compass set rotation, and we get the opposite of the azimuth. Now a plus we can do to the text of the azimuth is to add the corresponding string. So if we have 0, we are in the north, and so on. So we create a string called where, and if we are in this range, we have north, northwest, west, southwest, and so on and so forth. Okay, the last thing we have to do is to set the text of the text azimuth. So text azimuth dot set text. We have the azimuth value plus the degree symbol and then the where string. Okay, before simulate, let's correct mistakes that I've done here. instead of m magnetometer, we have to write m last magnetometer. Okay, now we can test our app. My advice is to test by connecting your device in the debug mode to your PC, because if you test with the emulator, you can see that when you change the position of your device, also the azimuth and the orientation of the compass image change. Okay, let's start our simulation. Okay, and finally we get our compass app. As I told you at the beginning of the video, if you have any question, you can write to us on the comment box below, or you can go to our Facebook page. Thanks for watching.